All right, first up for our gas laws is Boyle's law. So Boyle's law, you have a volume of a gas that's going to be dependent on the pressure applied to that gas. So what I need to know is that I have a pressure times a volume that's equal to a constant value. So if I'm going to keep a constant value, that means that if I have a changing pressure and a changing volume, as one changes in one direction, as one gets bigger, the other one's definitely going to have to get smaller so that I can multiply and still get a constant value. Right? What that means for us is that those two values are inversely proportional. Definitely a big ACT thing. Make sure you know that as one thing is increasing and the other thing's decreasing, that's inversely proportional, right? If I was to graph something that's inversely proportional, right, I can put pressure and volume on different axes, start anywhere that I want to, right? And what I'm saying is that if pressure increases, the volume would have to decrease, right? If it increased some more, the volume would decrease a little bit. And as the volume increased, pressure would have to decrease, right? One's always doing the opposite of the other. As you continue to draw and connect the dots, you eventually see that you have a curve that'll fit that data that actually approaches two limits, right? Zero for both things, because it's not possible to have a negative pressure and a negative volume. So as you approach those axes, you have to get closer and closer to zero, but you can never reach it. This kind of curve is called a hyperbola. It's a hyperbolic curve. Anytime you see that kind of relationship, that definitely means that it's inversely proportional. If you see data graphed like that, that is definitely something you might see on an ACT. But for our purposes right now, we just have an equation that we're dealing with that has to do with pressure and volume. So P1 V1 is equal to P2 times V2. We're just going to use that equation to solve problems. One thing that has to be true in order for this law to work, the temperature and the amount of gas have to be constant. I can't have a changing temperature and volume because both of those things can affect my pressure. And I can't have a leak in my balloon. A lot of these problems are balloon type problems because that's one of the easiest way to have a controlled system that can change volumes, pressures, temperatures, things like that. But I can't have a leak in my balloon or I'm definitely going to have it end up being smaller, right? So an example to work off of. I gave a lot of you guys a worksheet yesterday and I told you to put a number 1 on it, right? Number 1 on the top just so that we would know that's the first one we're supposed to do. If you don't have it because you didn't pick it up after school, you can just write them down on a piece of paper. These were just examples for us to go through for each gas law. So number 1, on number 1, right, that first question talks about a balloon that contains 5 liters of helium at sea level. Right? If released, what would be the volume when it reaches 1 mile in the air? And it says that the new pressure would be 630 torr. So all I need to do on a problem like this is identify what I have, right? I was told that the volume is 5 liters, so I'm just going to write that down. And I know that it's at sea level at 760 torr. Anytime you see the at, that means that those two things go together. So my pressure is 760 torr, right? So these go together. They could both be the 1s or both be the 2s. It really doesn't matter how you want to do it. But then it wants to know what would be my new volume, which would be a V2. I don't know what that is. When my new pressure reaches 630 torr. So now I have all the things that I need. I just need to plug them into my equations, right? I know that V1 times P1, so 5 liters, times 760 torr, is going to be equal to V2 times P2. So I have a V2, or just an X if you want to put that in there, times 630 torr. And we have liters and torr going on here in this problem, but it really doesn't matter as long as your units match. Because my next step in solving this, in order to get V by itself, I got to divide by that 630 torr. And that moves it over here. This torr cancels this torr. As long as your units match, it really doesn't matter what you use for volume or pressure. So you do have to be careful, because sometimes I'll give you one pressure in atmospheres and the other pressure in torr, so you have to convert one to match the other. Or maybe I give you one volume in liters, one volume in milliliters, and you have to convert one to match the other. But as long as your units match, this is pretty easy. So all I have to do is take 5 times 760 and divide it by 630 here on my calculator, so I can get an answer that is 6.0317, right? But I only need 2 sig figs, so I'm going to make it a 6.0, right? 6.0 liters, since my other unit for volume was liters. My new unit is going to be liters. But that's how you do a Boyle's law problem.